Hello, my name's Nicola Simons and welcome to a short video about measuring friction. At NC Squared we provide testing and advice so you can understand how your materials will behave in service. A simple test we can perform is to take a plate and a pin of two different materials. Now the pin can be of various shapes. For example, we can have a button shape which creates a large area. We can have a sphere which gives us a point contact. And we can also have a cylinder which will in one direction give us a line contact and in the other an area contact. One of the unique features about our equipment is we can heat the base. Therefore the plate can be anywhere from room temperature up to 600 degrees C. The first stage of the test is to load the pin against the plate. This creates a stress within the pin and a pressure within the contact. Obviously this pressure is dependent on those shapes that we talked about earlier. We now need to apply a push force, which gives us motion. In this particular case, it's back and forth, or reciprocating. The clip here shows a plastic pin being tested against a plastic plate. The initial movements of the pin have allowed the two surfaces to bed in and make full area contact. The system is now primed, ready to measure friction. We need to determine the coefficient of friction. Physics can explain how we obtain this. Our pin has a weight acting upon the plate. There's a reaction force normal to this. We're creating a motion through a push force, which in turn creates a friction force in the opposite direction. The coefficient of friction is that friction force divided by the normal force. In other words, we're looking for a number below 1 if it's easier to slide an object than it is to lift it. During testing, we plot coefficient of friction against time. Let's start the test. Let's see that a bit slower. As the pin started to move, the coefficient of friction went up, creating a peak, which then came down to a steady state amount. We call that initial peak the static coefficient of friction, as it was the friction force required to move it from a static condition. The steady state friction is the dynamic coefficient of friction, i.e. equating to the friction force required to maintain that movement. Here's an example of real data. In some material pairs, the dynamic coefficient of friction is higher than the static. To understand the true dynamic coefficient of friction, one must run the test for some time. Here's our reciprocating system. This time it's a plastic pin against a steel plate. The 4 pipes form part of the heating system. The bridge across the pin head is the loading system. The horizontal friction force is measured directly through the base. The cam system allows us to select different stroke lengths. Obviously, with time, we start to generate wear, which is a whole nother subject for another time. Thank you for listening.